Welcome to another teardown video. This time it's a power supply, switch mode power supply from TDK Lambda. This model is called Vega 650. So that means it's a 650 watt, a total watt output, I guess. And they are fully configurable. I don't know if the configuration is something the customer is supposed to do, because this looks a lot like this one is specially configured from factory, and it also looks like it is configured with all the right cables, both on the input and output for easy server install. I got quite a few of these from one of my sponsors, and thanks a lot for that. I was told that it's not all of them that works, but most of them will work, so I don't know if this one is gonna blow up or just not work, or why it was replaced due to something, instability or whatever. I'm a little bit confused about this module. So that is 6 volt 10 amps and 6 volt 6 amps. And see, the positive of one and negative of the other, there's a resistor. So that is between two outputs, and if those two outputs, they're floating, that means you can put them in series or in parallel or whatever you want, right? So that means this as long as this connection is open, because they're not connected this connection is not in, right? So that means there will not be any voltage across the resistor. So I don't know exactly what's going on here. This is 6 volt 25 amp in really this cable, and also 25 amp, and now they're using a thicker cable, so maybe they're not using full load of this. So I'm a little bit curious about what happens when I power this up. It is really big and nice. Whoa, it looks like it's super good quality. At least they're quite expensive, so this is considered some kind of a score, and hopefully it's gonna work. Let's test it first and then tear down later, right? I think I've done my very best. All the different outputs, they're connected to either loads on voltmeters. We got some loads, and they will also read volts as long as I don't load in anything. So actually I got 4 voltmeters here at the start, so I should actually monitor all 4 outputs, right? And also I measured no connections between the two, this minus and this positive. So that means this minimum load here will only be applied if you short circuit those two center points here, right? And I don't do that right now, so maybe this power supply will be unstable, so there must be a reason for this. So that is something I'm a little bit worried about, what's gonna happen. So we're gonna power this up together, right? We're gonna crank up the voltage to 230, and about that we're gonna stick this in, and action. Whoa, 50 watts in standby. Are you kidding me? 56 watt, that is a lot of standby. Ugh. But there's no. I did of course check the earth wire here, and everything here is earthed, so that is why I can always touch metal. I'm not a complete jerk, you know. So what have we got? We got 6 volts, and that is also 6 volts, right? And then the 24 volts, and that is interesting, because I need the 24 volts and quite a lot of amps. And so how about we just, yep. So that is 25 watts. And what happened? I added 25 watts, and now we got 75. Okay, so 75 input. Let's crank up the current another 2 amps. Let's give 50, right? So that is 100 watts input. So that means an efficiency of 50%. I am not impressed, but let's give it. Let's give it 100, right, and see what happens. Okay, so now we got 100 watt output. Oh, look at that, 154. So that means 75% efficiency. So it's getting better, right? Let's load some more. I'm just loading 2 of the outputs with 300 plus 100. And it seems to be doing quite right. So that is 400 watts of output and 488 in input. 488 in and 400 output. So that was 82% efficiency. I'm not really impressed. And of course, it's I'm only loading one output here barely, and this one is also only loaded barely, right? So, and this one is not loaded at all. So I think it's time to tear this down and see if we can take out 2 of the modules that I don't need and run it entirely on the 24 volt module. Maybe this will give me higher efficiency. So how are we gonna open this thing? Yips, like that. It was actually quite easy when you do it right, when you figure this out. Of course you need to push this down and push it up like this, right? And this screw is of course not for any of that. But over here, there was a screw in the other side. Okay, only one screw. And the end module prevent the top lid to slide back. So that is, well, so that needs to come off just a little bit like that. And of course I was an idiot. I took off this screw and then kept pang, something fell inside. And it's this that holds the rectifier. So I'll have to fix this in a second. But let's just enjoy this power supply for a second. It is amazing. So the fan blows through this hole. I want to see what is in here. And that will be the 3 configurable output modules, but it's really not user configurable. This is done from factory. And the reason I can say that is because this is their soldering. It is soldered directly into the module. So this is a primary input to this module. And then there is like a pre-regulator and after regulator on this board. That is like a standalone after regulator. And then all of them communicates back only on a single bus. Maybe this is just overloading or shut down something. So it's just in parallel. I don't know if that is any communication of such. But look at this transformator. So that will be the secondary, different secondary windings with plastic isolation in between. Wow. That is just some of the most sexy. Look at that. Just a little bit of almost nothing compared to the space available in this transformator here. It is just this. Almost nothing. And that is the secondary windings. So this is where it goes. And on this board we will have rectifiers and after regulators again. Ooh, this is some beautiful, beautiful design. Let me see if there's an easy way to get in and see what they got in here. Also, I saw here on the bottom plate where the probably regulators, or maybe those are, Yips, look, this is diodes. So this is just... Nope, this is a FET. So there's a FET and... But how can those two be isolated? Ooh, we got a lot of good stuff here in the back. I still don't understand. Because I'm missing a lot of components here. How is this possible to regulate both of them? I'll try to load one of them and see if the other one goes off. That because this comes from the same primary winding, but all 3 power supplies comes from the same transformator. And I tried to load one of them and the other one, and also not the other way around, and it didn't affect the 2 6 volts here. That was just rock steady. Oh, this is beautiful. I got no idea how expensive this is, but this looks a lot of expensive. There is everything nice in this one. Phew, that took a little bit of figuring out. So there's a nice isolation plastic insert here. And then I just unscrewed everything and then wiggly fooling around for a long time. And then finally the darn thing came out of the case. And it turns out that the mains transformator thing is actually something that just slides in here, and just 2 connectors goes here, and that is the primary side. What do you know? So this whole thing is just those 2 thin layers like this. That will be the primary, and then the secondaries, they will be like this. So it's just that easy it is to reconfigure those. And all you have to do is unclick this. I tried to figure out with a screwdriver here and how to pull this up. I still haven't really... Oh, okay. It's the lock things here. That is what was tricking me. Because I want to see if I can take off the 2 6 volts. I don't need those. I only want all the power in a 24 volt. So that is my goal, to see if it will run and stable. And then there's this communication interface. It says here voltage aux and then over voltage protection. So that's probably what it's doing. Some auxiliary supply. But why is this connected to an... Okay, how is it possible to have an auxiliary supply with only 1 wire? That is confusing. And I still haven't figured out, how is this possible? 2 isolated outputs, regulated and everything individually. 1 FET, 1 double diode, and a lot of small stuff. That is really cool. How did they do that? And this is the 24 volt, 25 amps. With only that. And I guess this one will be more or less the same. Yeah. With another inductor like that. So this one is a single version of this double version, but we need some transistors. It's confusing. All right, let me try and pull this apart. That was tough. I nearly broke everything here. But look. And this is the lock that is nearly impossible to pull out. And this is the first secondary winding. So I mean, we got 6 volts output in 2 different outputs, right? And all it takes is 1 winding. Really? Or how many windings have we got in this thing? Or are they connected in series here, or are they the two individual windings? I need to take an ohmmeter and then I will try and be a little bit more intelligent about my guessing here. What I want to show here, this is the minus of the one output and this is minus of the other output. So if I take the ohmmeter and measure from one minus, see, this one, there's absolutely no connection. But here, on this winding, so this and this, that will be one of the windings. Look at that. And if I go to the other output here, no connection, and then the other one is that and that. And what we got here is two windings equals 6 volts and two windings equals the other 6 volt, and that is it. And this is the 24 volt output that I really want. And we got a primary winding on one side, and it is of course fully closed and fully shielded, and that is 1/2 of our 24 volt. Okay, they're just up against each other like this. Okay, look at that. How many windings is that? Oh, that I didn't see coming. Why is it like that? So we got... Really? I thought they would be identical. That is weird. No, okay, they are identical. Oh, there are some smarties around here. See? And I bet they're connected in series here. Okay, so this is our 24 volt. Great, so we keep this. And then the last 6 volts I'm gonna take away, and then I'm gonna see if it boots up. I don't know if it's wise to try this without the casing or anything, but come on, let's have some fun, all right? So I connected the load here and just this one module, and we'll see if it goes into fail or whatever happens. Okay, power on. Really? 47 watts of input and 24 volts of output. Let's give it some amps. Okay, it works. Oh, that's already a lot better, because now everything is focused on my winding. Oh, that is great. 155. Let's give it some more amps, right? Okay, so that is about 300 watts of output, and it's still running like that, and 357 input. So now I am happy. Now we can put it back together. So here is how it works. Let me see if I can get some... Can I not get some light in there? No, I cannot. Let me try and turn on some extra light. What you see here is a full bridge. The primary side is a full bridge in there, and that will be the capacitors for the full bridge. This inductor is actually the power factor. So all this out here is the power factor system, and all the power parts out here, that'll be the input filter and common mode chokes, double common mode chokes, and the rectifier. And then we go for the power factor with the big inductor here. So that is what it is. Really, really fantastic. It's beautiful. So I'm done. It's assembled and adjusted. I could easily adjust it up to the 26 that I needed. No problems. And I'm really, really happy about this power supply. Thank you a million times, my wonderful sponsors.